Thank you for showing up so early. My name is Manfred. I'm the author of this wannabe catchy title, Don't Panic When Containers Are an Option. Let's be honest, don't panic when containers might not be the best option available. Among others, wouldn't be quite as fun and catchy. So thanks for showing up. And I hope I won't let you down on this. So many thanks to our sponsors. Without them, it would not be possible to do such an event. And it's great to be here in person after this weird time we've been through and see so many faces, or not see so many faces, but I think we'll get there eventually. Well, yeah, as already stated, I'm Manfred. I've been a software engineer for about 15 years now, and I've done some freelancing, research and development. But for the last 10 plus years, I've been in automotive engineering with a company called Case Engineers here in Austria, in Graz, which is the second biggest city. And yeah, so I've done a couple of different programming languages, had my hands on different frameworks and stuff, but it was not until 2016 since I first got in touch with PowerShell, and which was because we've basically rebuilt or set up all our development boxes and build servers and stuff like that to be like fully automated when doing setups via Chocolatey. This is where I first kind of got my hands on PowerShell and basically continued to use it for my professional career ever since. So I'm not famous on the internet, but you can find me on Twitter and also doing stuff like Chocolatey community moderation and maintaining the box data project, which is definitely something you should check out if you know what Chocolatey is. Well, so I'm going to assume you all have more or less done something with containers. So is there anyone here who has not yet dealt with containers or container tracing? Okay, great. Containers are great, aren't they? They basically solved a lot of problems, but they also solved kind of the idea that we won't have to worry about certain things anymore. And especially in the DevOps-ish era, I'd like to say we've been sold the idea that there are certain things that just won't happen anymore. So originally, when talking about development and operations, and I'm looking from a developer perspective, there's always been like this wall in between, and you all know this meme where developers just take something they want to put out to operation and they throw it over the wall, and then it's operations problem. And the famous saying, it works on my machine, it just does not happen anymore with containers, right? So we've got something completely different now. Who can relate to this? Yeah, a couple, I thought so. So it's better, right? It not works on my machine anymore, it works on my container. So we not necessarily lifted, but definitely shifted the problem away. So it's containers now, so no problem, right? Well, unfortunately, this happens. And it even happened to me once that I was taught to, it happens on my container, but it happens on my cluster, which is even worse. So when trying to set up K3s on a Raspberry Pi cluster, unfortunately, there's not everything available for ARM-based computers yet. And yeah, it's really annoying when you read somewhere, yeah, but that should work. It works on my cluster. So are you sure you've got everything set up right? Not a good thing. So this slide is a bit unfair because there's a lot of value in containers and what containers provide us with and what containers can give you. So I'll spend about 1/3 of this talk talking about what containers actually give us and how they can provide value. And then also tell you about when, in my experience, containers may not be just the best option or a fit in a certain scenario, and what you can do in this situation. So, of course, containers, when done correctly, containers can vastly improve our development cycles and throughput, productivity in general. I think that's a no-brainer. Also, they simplify configuration and deployment. So we've got these like fancy descriptive configuration files where you can say, okay, this container needs to have this and this dependencies and run on that kind of hardware. And basically, you create a file describing what should be run where and just should work in theory. So I'm not only talking about Docker. Obviously, it's the most sophisticated choice or the most commonly used choice, but there are other things like Podman and OpenVZ. And I'm throwing them all into a bucket here because most of them work kind of the same. Some of them are demonized, some not, but don't worry about that, okay? With containers, we got never seen before security features like real application isolation without having a huge hit in performance. Because we were able to do application isolation previously. We had the choice if we just use multiple bare boxes, or we could use just full-on virtualization, operating system virtualization, which of course came with a bigger overhead than containerization, but we had pretty good isolation there. It just was a different trade-off. And of course, we can do those lift and shift principles that were introduced with containerization. We can split up monolithic applications if we want to do like service-based development. That is what containers really are great for. And if we split up our application into different services and so on, then we can, of course, lift and also shift those containers away to run somewhere else, to have them highly available, whatever. So I think we can all agree on those points so far. Those are pretty basic. Now let me get into a couple of things that might be a bit biased of my experience and what I've done with them. So I see containers as a really great tool when dealing with state in development environments, such as not only dev boxes, but also build servers and production servers, because we are able to try different things, have like different compiler versions when doing like low-level C++ development. And it's like, it comes at no cost really. So we can pull a container, try something, see if it works, throw the container away, take another compiler. And it basically helps us keep our systems really clean. So in an ideal world, our operating system just would basically contain of an editor, some container engine, and we're done. So we can do most likely anything in containers, right? So containers are really super convenient. But containers are sometimes just not really available in special environments, such as when we do need low-level hardware access, like when we talk to PCI devices. It's possible, but who's been using containers in Windows environments? Okay. Who of you has to support Windows Server 2016, 2012, Windows 7? Not so fun, isn't it? So we've got things like the Docker toolbox. Yeah, but no Docker Deck and desktop, of course. And those legacy operating systems really are not, I'll try to stay politically correct, so they're not fun to work with anymore. But we have to. And so containers are kind of weird in that area. And also if we really need high performance, and I'm not talking about like mining stuff, which obviously works pretty good, but when we're really talking about high performance CPU throughput, things like doing multiple gigabyte per second IPC, so inter-process communication, we're shoveling like 10 gigabyte from one process to another in 1 second. We're not worried about milliseconds, we're not worried about microseconds, that is where we count nanoseconds, and in this area, containers might be just too much of an overhead. And of course also disconnected networks. So I hope so that many of you raised your hand when I asked about Windows Server 2012 or Windows 7, that those networks are hopefully not wired up to the internet directly, and they're kind of in an air-gapped-ish environment, or at least have some really good firewalls in between, because that's what you definitely want to do. And in these kind of networks, you sometimes, or most likely, have to go an extra mile to be able to work with containers, because typically, you would expect to be able to reach out to the internet to just pull another server. And when working in such environments, you really have to put in a lot of extra effort to get there. And of course, containers actually do add some complexity to our environments. So when you've been working with containers, it's most of the times not just, okay, now I've breaking this service out and I've got now 1, 2, 3, 4, 5, 8 containers. No, usually it's more than that. So who's been working in an environment where they've got 5 containers or less for an application? Okay, 1, 2. It's not the norm. Typically, when you do go in to containerizations, you got a lot of containers, so basically you split one application or one service, one special thing per container, so you can really take care of that. But then you've got a lot of containers, a lot of versions, a lot of things you need to take care of in extra. So containers kind of get quickly complicated to deal with in certain environments. You've got a lot of containers when dealing with offline environments, when dealing with legacy Windows environments, which obviously for the PowerShell conference, most of us are dealing with Windows environments. And yeah, you really do have to do a benefit cost analysis if you want to have containers in a certain environment or if it's just too expensive. So I really want to get my hands on some code now, what we can do when containers are not an option or not the best option. And we'll have to set up some example scenario. So we're talking about a CI/CD environment with like kind of the special hardware requirements I've been talking about earlier. So we really want to have low-level PCI access. We'll be working in a Windows environment. We are working in a disconnect network, so no network connection available, or at least to the internet. So we'll have to set up like an internal Artifactory server for packages we're going to need, like npm, NuGet, Python packages, whatever. And yeah, we want to have reproducible builds. So reproducible builds would probably be a conference on its own. Just want to state that when you're in software development, when you're in operation, at any point of time, you want to be able to basically create the same version that's run on a customer side again from scratch, basically. So you might want to be you definitely want to be able to put in a minor bug fix that just fixes some security issue or a bug a customer is experiencing and rebuild the same version again that this customer has with just a tiny bug fix. So for this, you want to have reproducible builds. And the one-on-one on reproducible builds, sorry, just let me grab a sip of coffee. Much better. So the one-on-one on reproducible builds is put everything in source control. So really everything. Do not have any external input. Do not use some license files, key stored on a network share that's going to break your neck at some point. Please do have automated software setup and configuration deployment when you're in such an environment. And this does not matter if you use containers or not. You always want to be able to set up your boxes, your containers, no matter if they're metal or in a virtual environment or in a container. You want it to have set up automatically. Use some kind of package management, use some kind of configuration deployment. If you do not have such things already on Windows, take a look at Chocolatey, take a look at Ansible. They're great tools and they will make your life so much easier. And also put this in source control, please. And what this talk basically is about and what I hinted in the description is state. State is a problem in many environments. To know your state, you've got to monitor your state. You've got to know what the state of your environment is. You need to know what might change your state, and you want to manage your state. I'm not going to talk about PowerShell DEC here. It's obviously a tool that we've been given, but when talking about the environments I've been talking about earlier, so Windows 2016 would work, but below that, we're in a weirdish zone. I think DEC requires at least PowerShell version 3 or 4. Yes, there's DEC. It might do some of the things we want to, but not all of them. So yes, there's DEC, but it did not have all the bells and whistles I required, so just leave it aside for now. In offline environments, I already told you, if there's anything relying on the public infra or services, such as external packages, we want to have them internal. We want to have them on an Artifactory server, on a ProGet server, and available in our air-gapped dish environment. If we're dealing with legacy systems, just do not reach out to the internet at all. If we rely on public source code, of course, this also needs to be pulled in, because we do not want our builds to reach out to GitHub or GitLab, basically. Of course, also, what is if this project vanishes? It happened before, so yeah. Also, if we do have in our environment like remote cloud agents, this is not going to work on the long run. So basically have everything internal. And there might be some other things I have not listed here yet, but just think about what would happen if you pull the plug to the internet. Would you still be able to build whatever, or is your CI pipeline going through or not? And it does not really matter if we're in containers or not. These are problems we always have to deal with. So those won't go away. So containers are great, but sometimes not fit for the job at hand. And now we're going to do an actual demo. So I've set up a Jenkins server just on this machine here, and I've set up so let's just get in here. So this is the pattern I want to emphasize, and we're trying to implement basically. So if there are any questions, we've got like 10 minutes at the end, but if you want to just interrupt me whenever. So going to start this so the Jenkins server is now running. Oh, great. And we're going to start a Windows 2022 server. Also, yeah. Nope, that's the wrong address. So, okay, right. I've logged into this Jenkins instance, and there should be 2 executors. So the one is obviously still booting, should be here in a second. I've got a couple of jobs set up. So let's say we do our CI/CD environment driven by basically a PowerShell script. I've seen this quite often in production. So basically you check out some repository, you check out some tag, and there's this one build script which should be doing most of the work, which does anything. Of course, you can do some fancy stuff like pulling cake or psake, invoke build, whatever. But just state there's this repository and there's the script we call with parameters or not, and then everything should be done automatically. The thing with legacy systems is that often these kind of build scripts do have some dependencies. So they might install some software during the build, which is not good, or they just, let's say as an example, they ensure that 7-zip is available because they want to compress something or extract something during the build, or they install NuGet console runner, or they will probably even reach out and install Visual Studio build tools, something like that. And this is something that really is not that nice because it mangles with the state of our servers, and we do not want that. So when, and it should be available, not yet. It's set to be running. Okay, just a second. I had it on suspend. Just let me restart this, then it should work. Okay, should be there in a second. Sorry. So when something in a build process changes the state of the server, we want to be aware of that, and we want to basically take the server or the node, Jenkins node, back to where it was before the build happened. This sometimes can be quite tricky because we've got time. So I'll just take a look at how this job is wired up. It's basically what I told you previously. So there are some parameters, so which reference or which build tag or which stream you want to build. There's this parameter that tells us if we should use the verbose switch when calling this build script. And basically this is all the job does. So I've got a helper function that tells me if the verbose environment variable, which is what Jenkins does. So whenever you add a parameter, Jenkins will convert it to an environmental variable, and you will have to query it this way. So then there's this anti-snowflake module, which is what I came up with for this presentation, which should remove the state from the server. And what this anti-snowflake module gives us is this push state and this pop state commandlet. And we're going to have a look at this in like 2 minutes. After we pushed the state, so in here we get us some information about what state the server is in. We set the location to some Git repository, we check out the build ref. If something happens, we just bail out with an error. And then we call this build script. And we really do not know what's in that build script. And different versions of this repository do have different versions of this build script. Some might install software, some might change registry keys, and some might install and start services on that machine. Let's think about really a real-world example would be we do a build. This build really needs like low-level hardware acceleration and access, so therefore we cannot containerize it, because in like a C++ environment where you do like pipeline, cache pipeline optimization, so your structures fit in nicely to this special CPU architecture you're building on, you do not want to have a container in between, so you really need to build on that low-level machine. And after that we're running some tests. And in that case, somewhere in between, some software gets installed. And we really want to reuse that agent for like an older version of the software, which then would install different versions of the compiler of whatever. And we want the state to be gone, because if you've got like MSI installed and you want to install the older version, it will just bail out and say, hey, I've already installed this ID with a new version, so don't care. And it will break our build. So we want to get rid of the state. So this is why we do a pop state in a finally. So we try something, and no matter if it's successful or not, finally we're going to pop the state, and we want our server to be clean again. So this anti-snowflake module here. Can you read that? Is that okay? So you've seen the push state and the pop state. I'm going to go through this kind of quickly. Okay. So this push and pop, I tried to orient myself with push location and pop location, which I think all of you are familiar with. So we take a parameter, which is a custom object. It might be null, so we can push state without any given state, so then it will collect the state before it stores it. We've got some ugly some ugly script global variable, which is only available in module, which actually captures the state. Then we get the current state, so we'll have a look at the get state in a minute. Some verbose output, we print the state we've gathered when we are using the verbose switch. And then this is something that might be of interest for you, because when doing a push-pop idiom, we basically think about a stack, right? So we push something on top of the stack, we push something on top, and then we pop off the stack. Thing is, implementing a stack in PowerShell doesn't really come off that easy, because it's not like a one-liner. But what you can actually do is use array deconstruction and just create the stack inverse. So you actually take an array and add the elements in front of the array. So what you really do is you use the current state and create a new array with the rest of the already existing array at the end, and assign it to the existing array. So basically you're creating a stack, but you're adding in front, in front, in front, in front. And when we do pop state, so this is basically push state. And of course, when we pass a state to push state, then we want to set that state before we push the current state onto a stack. And with pop state, we've got a pass-through switch, so we might want to take a look at what state we applied and receive it. So if there's no state in the stack, just return right away. And this here is really neat. So this is the deconstruction of the array. So I I say state and the rest is the current array. What this does, it just takes the first element and leaves the rest. So if I'm going to show you this because I like it that much, we're going to create an array. And if I say first, rest, and have a look at the first and the rest. So we just took the first element apart and we just build a stack just inverse. If you did not know that, happy to help. It's really great. It's like a cool thing to know when dealing with stacks or when you require stack at one point. So after that, we taken off the first element, which would be the last thing we popped. We pushed, so we popped the last element we pushed. We're doing some verbose output, and then we're calling set state. And then the pass-through switch, we either put the state onto the output or not. So now you've seen the set state and the get state. The push pop, let's have a look at get and set. So this is not a full example, it's just to give you an idea what the thing I'm talking about could look like, and a fully implemented version of this, which does take care of like everything that I can imagine, has like 500 lines of code. And I just wanted to keep it clean and simple. I hope, sorry, too many gestures. Okay, we're back online. I hope to be able to actually release this module in, let's say, next couple of weeks. It's kind of time consuming when you have 2 little kids and want to do such things besides. So when get state, we currently do only take a look at 2 things. We take a look at all the services that are currently running and are installed on a machine. So we just use the get service commandlet and we store this. And I'm a big fan of Chocolatey, and basically all my software installations and uninstallations are done by the Chocolatey package manager, which is great on Windows because it works both on clients and servers and even in older environments, which only get PowerShell version 2. And what I do here is I just query the location where Chocolatey packages live, ID, I just parse the XML, the new spec, and I read out the ID of the packages installed in the version. So I've got a full list of all the packages that are installed and of the services that are running. If you've got a Chocolatey for business licensing, you can use Chocolatey Package Synchronizer to have a full view of all of the packages that are installed, not only those, or of all the software that's installed, not only the packages you installed via Chocolatey. And when you've got this business license, you will also see packages or software that has just been installed via MSI or Exe, because it will show up in your inventory even though you did not install it via Chocolatey. So that's neat. So this has been get state. It's like really easy. And with set state, we get in a state we want to apply, and we get the current state, and then we basically have to diff it. So what has changed to the state we currently have to the state we want to apply. So here we go over all of the packages, so the software that's installed via Chocolatey, get the ID and take look the previous package up and restore the state. So I pass in the wanted state and the given state. So the given state is the current state, and the wanted state is the state we want to apply, which we pushed to the stack earlier. After that, because we will miss things that have been deleted, because it's obviously not in the current state. So there are actually cases, or we stumbled upon, where a test deleted stuff from, or so it actually did an application installation. During the application installation, another application has been removed, and then it was gone from the server, and where did it go? Yeah, well, the build or the integration tests mangled with the state of the server, and it's bad, and therefore you have to do things like this, and also explicitly delete stuff that's been added and remove stuff and restore stuff that has been deleted. This is basically the same for the services. So you've got a restore service, and you pass in the wanted and the given state. Just taking a look at restore choco state now. If we do not want this package to be installed, so if wanted is null, then we do an uninstall. If it's not given, so if it has been removed, then we install the version, the ID and the version again. And if the installed version does not match the given version, then we just force install the version we want it to be. Otherwise, nothing's changed, everything's fine. So I kind of need to speed up a little because I'm running out of time. So I hope this agent is available now. Yes, it is. Awesome. Yeah, I've prepared a couple of jobs. I'm not going to print the PS version table just to show you that the built-in node is actually a Linux node and the Win2K21 is a Windows node. So I'm just going to start the job now that says sample software and service changes. Yeah, just keep everything the same and build it. So now there's this build running. Actually, what this does is it sets up some requirements. It uses Chocolatey to install a package called Chocolatey, which is a pet project of mine. Go look it up. And then it starts a service called MyAppService. It does some benchmarking, and the build is done successfully. After the build is done, it determines, hey, the package Chocolatey is new. We're going to uninstall it again, so the state of the package service unchanged. Yeah, and that's basically it. So the service MyAppService obviously has been running because it has not been stopped. So this is something we're going to change now. Just going to into the service and stop the service. So the build will start it and we'll see it get stopped afterwards. Come on. Oh, damn it. Sorry. See, it's running. No, stop the service. And what we are going to do now is that we rebuild the job and set it to be verbose, so we can actually see what the model is doing below. And we're getting a bunch of output because we're dumping all of the state we gathered. So there's a lot in here for services, really a lot. But this information is all valuable because when you kind of lose the state or the state is modified, you want to know as much as possible to be able to restore the state afterwards, if you have to. So I'm just going to go to the live view again because this is too much. So it's already run through. And what I want to see here is setting state. We get all these package already installed in the correct version, package already installed in correct version. Then there is this package is new, we're going to uninstall it. And hopefully now there should be, this service is not in the, yeah. So here the MyAppService wanted state is stopped, but is running. So because the job set it to running, it might have installed the changed the install location. So we also wouldn't have to restore that. But anyway, we just restore the state. So our server or Jenkins node is now in the same state as it's been before, even though this, I'd say, unclean build changed a bunch of state, which we do not want to. So going back to the presentation. What have we seen now? So we've seen this pattern, which is not hard to understand. It's unfortunate that there are situations where we kind of need to come up with this kind of things. But actually, for processes and services, there's PowerShell. For applications, well, you guessed it, there's Chocolatey and PowerShell. For registry keys, so it's not hard to come up with basically the same thing, there's PowerShell because there is the registry provider. And guess what? Even for files, you can use the Win32 shadow copy module, wrap it in a bunch of command sleds, and use PowerShell to even restore full-on files, much more. So it gets a bit tricky when you're working with shadow copy because this actually the node will most likely go offline, and you will have to do this in a like downstream job. So your initial job runs through, and your downstream job, which you don't really care about, it just resets the state, then will abort at some place because you do apply the shadow copy or restore a shadow copy. But yeah, it's possible. So what do I want you to take away? Don't panic. We still know how to solve some basic problems such as these when we are not able to do containers for one reason or the other. One key to success really in this kind of scenario is keep everything, and I mean like everything, in source control, please. You do not have to control actually all the state of your nodes. You just need to control what is going to be changed, and this is something you typically know. So you do not really have to do VM-style snapshots and restores, but yeah, just the things you really know that are going to change. And you still can use containers where possible. So it's not that you do not use containers in general, because for one or the other reason, please I want to emphasize use containers where possible. It's for a reason that all people are going in this direction. So containers are great, and if they're not applicable, we've got some basic solutions, and we've got PowerShell to help us save the day. Well, this should be a Q&A slide. Yeah, we are. Thank you for listening so far, and I'd be happy to answer any questions if there are. Also, if there's no question, we can all go out and have a coffee. Thank you. And maybe, yeah, I will try to publish this kind of push-pop state module, let's say in the next 1 or 2 months, because 2 little children at home, it's time-consuming. So, thank you.